Assalamu alaikum dear students, this is International Islamic University, Islamabad School, Sahiwal campus. Science grade 6, lecture number 3, lesson number 13, electric current and circuits. Students, bring your science book, open it and write date and day properly. Listen to your teacher attentively and mark all the important points said by the teacher on your book. The first topic that we are going to discuss is electric switch. A switch is a simple device that either breaks the circuit or completes it. So switch is basically that device that is used in a circuit to break the circuit or complete the circuit to allow the flow of current more easily. In our houses, we have switch to turn on or turn off electrical appliances like a bulb. So we can use a switch at our more convenience. So we can switch on and off it more easily. The switch is connected in part of electric circuits and enable us to use the appliances at our own convenience. When the switch is in off state, it does not allow the current to pass through the electric device, so it will break the circuit. And when it is on, it allows current to pass through it and it will connect the circuit. So this stops the flow of current through the appliances and they can stop working, and this also can allow the flow of current through the appliances and they can also start working. To make an electric circuit operate at our own convenience, we need to add a switch to it, rather connecting the wires. So when a switch is in off state, it does not allow the current to pass, and when it is in on state, it allows the current to pass. So we can use it more easily. We can turn on and off an electric switch, and with the help of this electric switch we can break the circuit and we can connect the circuit. So an electric bulb that is connected in an electric circuit, that is shown in the figure 13.11 on the page number 138 of your textbook. It allows the easiest way to stop the flow of current is to disconnect the wires and to allow current to pass to connect the wires again. So if we see the picture of this electric bulb and electric cell, we can connect or disconnect the wires from any one terminal, either from the electric cell or from the bulb. We can connect or disconnect the electric circuit. Structure of a torch bulb. We can have a picture that shows the structure of a torch bulb that is connected on the both terminal and shows the flow of current from the positive terminal of a battery to the negative terminal and shows the on state of a bulb. And the second circuit that shows the connection of all the components in a circuit, but the connecting wire is disconnected from the terminal negative of the battery or an electric cell. So this shows that there is no complete circuit formation and there is no flow of electricity. So we can say that there are two types of circuit. The first one is closed circuit and the second one is open circuit. So if we define the closed circuit, we can say that a complete circuit with the switch on is called a closed circuit. There is a flow of current in a closed circuit. So in this slide on picture number 1, that shows complete flow of electric current from positive terminal to the negative terminal and shows the bulb in its own state, provide us an example of a closed circuit. So this type of circuit is known as closed circuit that allows current to pass through terminals. And by disconnecting any one of the wire, or if the wire is disconnected, this type of circuit is known as open circuit. So if we have the complete definition, we can define it as a complete circuit with the switch off is called an open circuit. So if the switch is off, or if there is any gap either by the disconnection of the wire, either by the fuse of the bulb or any other reason, this circuit will be known as open circuit, and there is no flow of current in an open circuit, so this is known as open circuit. The first picture shows the connected form of a circuit and the second one shows the disconnected form. So first one is closed circuit and the second one is disconnected circuit or the open circuit. Types of switches that are used in an electric circuit. All commercially available switches act like the switch shown in the illustration. For example, you have structure of the bulb that are different on the basis of the working point of view. So the on and off state of the bulb can be shown by these type of switches. If the switch is off, the bulb will also off, and if switch is on, the bulb will also on and shows the complete transfer of electricity. So these type of switches are easily available in the market. The first one example is on-off button, which are used in household circuits. The second one is push button or the slide button switch, which are used in torches, transistors, toys, etc. So in toys and torches we have a push or slide button. We move the button from slide distance from position A to B, and we can on and off it, or we can push it. The third one is press button switch, which are used to ring doorbells. So usually the doorbells have a press buttons. We press it and the bell rings. So this is the pressed button switch of the electric circuits. All these switches complete the electric circuit in the on state and break it in the off state. So switch is used to connect the circuit or disconnect the circuit. Now you can have some examples. The first one is on and off button, shows the 1 and 0, that shows if we have a switch in that state, we can see that the switch can be on and off. The second one is push button. We can push it as in torches or transistors or in the toys. The third one is pressed button, that is usually a common example of ring doorbells. On-off button, push button and pressed button. Electric switch or electric circuit of a torch that describe us about the electric circuit in a torch having a slide switch. We can have example of a slide switch and also an electric circuit of a torch. So the essential elements of an electric circuit are given below. Source of electricity or the currents. Second one is connecting wires. So the source of electricity or the current is basically maybe a cell or a battery that shows alternating current, AC voltage, and act as a source of supply of current to the whole circuit. The second one is connecting wire, and these wires are needed to join the various components of a circuit. Without these connecting wires, we cannot have a complete circuit, or we cannot connect the components of a circuit. The third one is electric device. It may be any device which we have to run this use up the electric flow in the circuit to produce light or heat. Electric device include bulbs, heaters, geysers and etc. The fourth one is switch. Switch is basically a device that is used to turn on and off the electric devices, and this is known as electric switch usually. So the simple circuit that can be designed using two batteries, a bulb, a switch and some connecting wire, basically all the components of an electric circuit or electric path, and these are shown in the diagram 13.13 on the page number 139 of your textbook. So you can have a torch having two batteries that are connected in a proper position from positive to negative terminal, an electric bulb. A reflector is shown in this, a bulb, plastic coating on the plastic casing basically of the torch, and a slide switch. So in this type of battery or in this type of circuit, we have used a slide switch to turn off and on the battery. So the simple circuits that can be designed using two batteries, a bulb, a switch and some connecting wire is that of the torch. So we can have example of a torch. The sliding switch is used here to make or break the electric circuit within the torch. Now you can have a picture of a torch, diagram of a torch that shows a bulb. A reflector is placed to reflect the light and allow it to pass through the various objects and allow the objects to lighten up, and plastic casing slide switch, and the electric cells. And these are the components of an electric circuit or a torch. So these provide us an electric torch that we can use. In the batteries are placed one behind the other so that the positive terminal of one is in contact with the negative terminal of the other. So both the batteries are connected in one behind the other. That will show that the negative terminal of one is connected to the positive terminal of the other, and the opposite terminals are connected with each other. This ensures that the current flows through both the batteries in the same direction. So if the batteries are connected in same terminal side, so this will not allow the current to flow, and we have placed in that direction that the negative of one battery connected to the positive terminal of the second battery. So this will allows a complete transfer of electric current through the batteries in the same direction. So if the batteries with similar terminals are placed in contact, the current will not flow through them and the torch will not glow. Electric conductors and insulator. In the electric circuit studied so far, we have used following components. The first one is electric wires that may be made up of aluminium or the copper, which allow the current to pass through them. Terminal of the bulb and the battery. We have discussed about the terminals of the bulb and batteries that both have, if we discuss about an electric cell, it will have a positive and a negative terminal, that is metallic cape and metallic base. And if we discuss about the bulb, so it will have a metallic tip that is of one terminal and the metallic base having the other terminal that are connected in a battery, which allow the current to pass through them. The third one is filament of the bulb that is made up of material of a metal. It may be a thin tungsten wire that allows the current to pass through them. Supporting wires. These supporting wires have plastic or rubber coating over connecting wires which do not allow the current to get out of these wires. So the plastic coating or the rubber coating act as an insulator to protect us from the electric current. Plastic or the rubber coating. This is basically known as insulator that prevent the flow of current out of the electric wires, that protect us from the electric current, and the plastic filling in between the terminals of the bulb shows that they are not exposed to each other. So there is a plastic filling in between the terminals of a bulb that shows that they are not exposed to each other. Both the terminals are separated by a separator. This can be a separator or a plastic filling as known as a plastic coating or the rubber coating, and also known as the separator. So all the materials which allow the current to pass through them are known as conductors. All the materials which allow current to pass through them are called conductors. Now we will discuss two type of materials. The first one is conductors and the second one is insulator. We will discuss them in term of electricity, and we can say that these are electric conductors and electric insulator. Conductors. All the materials which allow current to pass through them are called conductors. So these substances are basically electrical conductors. Examples are copper, brass, gold, iron, etc. All these metals allow the flow of current. So these are known as electric conductors. Insulators. The materials which do not allow current to pass through them are called insulators. So the type of material or the kind of material that do not allow an electric current to pass through it is known as insulator. The examples are wood, plastic, rubber, etc. Now we can have some picture of conductors and non-conductors. The first one shows copper wires, aluminium wires, steel wires, and any other metal that is basically a conductor. And in the second picture we have plastic wires, rubber casing over the electric wires, glass, cloth and wood. These are insulators that do not allow the current to pass through them, and the flow of current through any material that is conductor is just due to the presence of free electrons in between the atom of that substance. So an electrician use rubber gloves while working to avoid an electric shock. So here a cloth or the rubber gloves can be used to avoid electric shock. So it is because rubber gloves are made up of an insulating material that do not allow the current to pass through the electrician's body. So this is a type, or this is an example of an electrical insulator. Conductors are used to make electric wires and the electrical appliances. However, insulators are used to protecting layers over conducting wires. So if we take up the example of aluminium or the copper wire, it have a thin or thick coating of some plastic, and this coating is known as insulator, which do not allow the current to pass through wires to the electrician's body. So these wires are for the these insulators are coated over the wires for the sake of protection, so that we can handle them without harming ourselves. Okay students, this is end of the lesson. So you have to learn all the important definitions and all the topics of this lesson. Allah Hafiz.